Hi everyone and hi madam. My name is H. Chinesinu. I am from EC department and my roll number is 244g5a0404. And today I will present the topic about the poles and residues and how to calculate residues and identify the poles and how to calculate the poles like this. First of all, we will discuss about the pole. Why? Because we will find out the pole and we will know about the pole and what is residue. And first slide is what is meant by poles and pole and poles. Pole is a type of singularity, a point where the function becomes unbounded or undefined. పోల్ అనేది ఒక సింగులారిటీ ఫంక్షన్ అంటే ఒక సింగిల్ వేరియబుల్స్ అనేది ఉంటుంది కాంప్లెక్స్ నెంబర్స్లో. దీన్ని ఎఫ్ ఆఫ్ జెడ్గా డిఫైన్ చేస్తాము. ఇట్ ఈస్ డిఫైన్డ్ యాజ్ ఎఫ్ ఆఫ్ జెడ్. స్పెసిఫికల్లీ ఏ పాయింట్ జెడ్ ఈక్వల్స్ టు జెడ్ నాట్ ఈజ్ కాల్డ్ ఏ పోల్ of the order m of the function of f of z. If we have first order, the order of the function is 1. Now if we have second order, the order of the function is 2, and like this we'll define. And coming from next slide, the next slide is what is meant by residue. In my topic we will find and identify the poles and residue, and that's why I will define the residue. The residue of the complex function, it is denoted as f of z at a pole z equals to z naught is a complex number that provides key information about the behavior of the f of z near the pole. Firstly, we will find out the pole, and that pole we will find the behavior of the and that pole we will find the behavior of this complex function that represents the residue. This means that means the residue. The residue is often used in evaluating complex integrals, especially in the context of residue theorem. And this is the residue and the poles definitions. And we will coming from the problem here. How to calculate the poles and residues of the given function. And the given function is f of z. F of z equals to z square plus 2z divided by z plus 1 whole square into z square plus 4. First of all, we will find the poles, and after we on the poles, based on the poles, we will find the residues. Given function is z square plus 2z by z plus 1 whole square into z square plus 4 are the values of z. That makes the denominator 0 and the denominator is 0 when first of all we will find the poles and the given function of the denominators. The denominators are z plus 1 whole square and z square plus 1, z square plus 4 equals to z square plus 4. That's we will find the poles. First of all, we equals the each denominator equals to 0. And the denominators are z plus 1 whole square is equals to 0. The poles are found in z place. What value we will put, the equation becomes 0, and the z place is we will put -1. That's why the z plus 1 whole square pole is z equal to -1. What was the value is equals to 0, that was the pole of the given denominator. And second denominator z square plus 4 equals to 0. What is the value we put? It becomes the z equals to z square plus 4 equals 0. Z equals to 2i. I means is a complex function. We will put the plus or minus 2i, and the disorder is 2. and this means a pole of order 2, z equals to plus or minus 2i. And coming from, we will discuss about the and find the volts, and after calculate the residues. We will find the poles 2, z equals to minus 1 and z equals to plus or minus 2i. We will find at the both poles of the residues. Residue formula is residue of f of minus 1. We will find the pole of minus 1 and we become f comma minus 1 equals to limit. This was the formula. We will find the residue. Limit z tends to minus 1. We will find at the pole minus 1. That becomes z tends to minus 1. D by dz of derivative of we will find at the z plus 1 whole square pole. We will write z plus 1 whole square into f of z. F of z is f of z is what? Z square plus 2z by z plus 1 whole square into z square plus 4 into z plus 1 whole square. That's z plus 1 whole square and another z plus 1 whole square will become cancel. And coming from next slide, d by dz will remain. This equation is d by dz of z square plus 2z by z square plus 4 equals to u by v rule. U by v rule formula is u v dash minus v u dash by v square. Now substitute z equals to minus 1. We will derivate firstly we will derivate this equation. Derivative of the z square plus 2z is derivative of z square is 2z and derivative of 2z is 2, and we will write the z square plus 4 at same in this formula like that, minus z square plus 2z will become right as like this, and another v dash kada v dash కాబట్టి 2z వస్తుంది by v square అంటే z plus 4 whole square. And we will find the pole at z equals to minus 1. We will substitute the poles z place equals to minus 1. Residue of f of minus 1 equals to 0 into 5 minus 1 into minus 2 by 5 square. We will find that z at the pole of the residue is 2 by 25. We will find the residue at pole z equals to minus is 2 by 25. And same process, residue we find out z equals to plus or minus 2i కదా అనుకో. ఫస్ట్ z equals to 2i అక్కడ కనుక్కుంటాం. Simple pole, for a simple pole the residue is given by, we will write the formula like as it is like this, and z tends to we will change z tends to plus 2i, and the formula written like this: z minus 2i into f of z equals to limit z tends to 2i z square plus 2z by z plus 1 whole square into z plus 2i. And coming from another, residue of the 2i is simple pole. For a simple pole the residue is given by residue of same like this. We will find like this, and after we will not evaluate this formula u by v formula because of we will have the u by v formulas like this. We will apply the limits. The limits are 2i. We will replace the z plus in replace to the plus 2i. We will replace the 2i minus 4 plus 4i, 2i plus 1 whole square into 4i. 4 plus 4i 4 plus 4i plus 3i ఉంటుంది డినామినేటర్లో. దీనికి మనం డినామినేటర్లో కాంజుగేట్గా మనం యాడ్ చేసుకోవాలి. కాంజుగేట్ అంటే ఏంది? 1 ప్లస్ ఐ కదా, కాబట్టి 1 మైనస్ ఐగా కన్వర్ట్ చేసుకుంటే 1 మైనస్ ఐ ఇంటూ మైనస్ 4 ప్లస్ 3i minus 4 minus 3i minus 4 3i. It will become minus 4 plus 3i plus 4i minus 3i by 16 minus 9i square. 9i square means I square means minus 1. Minus 1 no minus 9 plus 25 అయింది. At the residue at the z equals to minus the symbol pole is 1 by 25 వస్తుంది. And after we will replace the same process at the pole of, we will find the residue z equals to minus 2y. Similarly, for z equals to 2y, residue, we will write the formula residue f comma minus 2y limit z tends to minus 2y z plus 2y f of z into minus, we directly, we apply the limits minus 2y whole square plus 2 of minus 2y divided by minus 2y plus 1 whole square minus 4y. And coming from another slide, same process will apply. Conjugate of the conjugate is applied to the both the numerator and denominator, and that will formula is becomes like this: is the residue of f of minus 2y minus 1 minus I into minus 4 minus 3i divided by minus 4 plus 3i minus into minus 4 minus 3i equals to 4 plus 3i plus 4i plus 3 by 16 minus 9i square. I square equals to minus 1. Already we will have the minus 9. Minus 9 into minus 1 in minus 1 equal, this will become plus 9. And the denominator will become, we will find the 7. And this was this will become to the 2 7 by 25 I. Therefore the residues are 2 by 25 at z equals to minus 1, minus 1 by 25 at z equals to plus 2i, and the residue z equal to minus 2i 7 by 25i. These will both combine minus 1 by 25 plus 7 by 25i at z equals to 2i. And finally, thanking you, ma'am.